All right, go live.
Perfect.
So we'll get started in a little bit here. While we're waiting, I'm curious where people are joining from. See a few people that have joined the stream already. You can mention it in the chat.
I even applied the correct colors to all of the models.
Good job. Livermore. Maybe I should ask what
Oh,
country.
whoever said Livermore, I think I know exactly who that is.
Oh, maybe you do.
Yeah, it's Mike. Yeah, Mike is a Fusion customer out in Livermore.
Germany. Is it a long? I know it's a long weekend in the UK, and it is for us in the US. My guess is maybe it's not a long weekend in Germany, or drilling and fusion is just that exciting.
Okay, well, that's the end of the countdown. Switch over to this guy. Let's go ahead and get started. Do you want me to kick this off, Al? Or do you want to give a little intro?
Maybe just as a quick kickoff, there's two of us here today again for the same reason. If you haven't met me, and Al Whatmo, I lead the product management team for manufacturing. CJ's on my team, specifically focused on some of the core aspects of the manufacturing solution as well as the tool library. But being trapped and not traveling, we thought it'd be fun to do some live streams for you guys. And today, CJ is going to walk you through drilling. But while he's doing that, I'll keep an eye on the chat. I can interrupt him along the way, ask questions. We love to steer CJ in different directions. So feel free to ask questions and we'll try and answer them as many as we can live. The more related it is to drilling, the more likely we'll do it right then and there versus maybe closer to the end of the webinar if it's a complete tangent.
Awesome. So drilling, it's an easy operation, right? On the surface, it's pretty basic, but it really does have some features in there that make it really powerful. Uh, and in some cases, you don't even need full blown automation in order to make selections and do things really easily. So I just wanted to go over the ways that you can use drilling in non conventional ways. Uh, and the first model I'll show you is just a simple block. To give you an idea of where we're headed, I also have a model here of a whole series, so the different ways you can select all these holes. And finally, we'll get to this part, which has, it looks like it's all the same holes here, but there's lots of variations in there, and selecting these and getting them in the right order might be kind of a challenge. So starting with this simple hole here, I just want to go over the different ways you can control applying a drilling operation. So I've got a section view here. We've added section view to the manufacturing workspace, which is a huge help. And I already have a setup, and I'm just going to select the drilling operation. And now we can start with our hole here. It's a 1/4 inch hole, and it has a flat bottom. And you know, when you drill holes, you have a drill tip angle 118 degrees, 140 degrees, whatever that drill will be. There's ways to adjust that. But let's go ahead and select a 1/4 inch drill. And you can see here I'm using the new tool library preview. And I have a 1/4 inch drill already in this document. And if you want to see how they use the new tool library and all its cool filters, there's a video for that we posted the other day. Okay, so I've got my 1/4 inch drill. I'll go over to geometry, and by default, the selection method is selected faces. So if I select the face for this hole, you'll notice that we get a selection that recognizes that hole from top to bottom. And the tool tip has gone to the whole bottom. It hasn't gone past it yet. Okay, so it automatically recognizes the top, recognizes the bottom, and the position. That's pretty easy. If I did want the tool to go past the bottom by that angle, on the heights tab at the bottom, there's an option called drill tip through bottom. If I turn that on, you'll notice that the drill tip will now go past the bottom up to the full diameter of the drill. And this will be calculated based on the angle that you put in the tool definition. So 118 degrees, 135 degrees, 140, whatever your drill angle is, this distance will automatically be calculated. And I need to hide my head because I'm in the way. I'm going to hide you too, Al.
Perfect. Hide me too.
Yeah. So this number down here, breakthrough depth, this is the additional distance that the hole is going past the bottom of the hole. So right now it's 0, which means we're not going additional distance past the bottom of the hole. If I type in, for example, 100 thousandths, you'll see it adds a distance to that preview. So the full diameter of the drill is now going 100 thousandths past the whole bottom. Okay, super easy. I'm going to set this back to 0. And for the last basics of just having one hole, on the cycle tab, you have lots of different options for your drilling operation. And we call these drilling, counterboring, chip breaking, but these are all meant to map to drill cycles on the machine. So for example, what we call counterboring is really just a drilling cycle that will dwell at the bottom of the hole and retract. Okay, so whatever drilling cycle corresponds to this selection will be posted out. Okay. A couple things to note here is that I didn't add any other features that would represent a drilled hole in real life. So like a chamfer on the top of the hole, the drill angle at the bottom. We can add those back in. So if instead of a extruded hole like this, let's suppress that feature. In the design workspace, I can add a hole. So I just need to have a single point here. Okay, finish that. If I go to create and use the hole command, I could then select the position that I want for that hole. It'll paste it right there. And when you use the hole command, you do get the option to add a drill tip angle. And then once I create that hole, I can also add a chamfer feature on top. 15th thou chamfers are about my favorite size. And now back in the manufacturer workspace, if I look at the section view, we have the chamfer on top, we have the drill tip on the bottom there. So what does it look like to select the face of this hole for this drilling operation? Let's go ahead and select our tool again. All right, so now I'm going to select that same face, but there's a couple of things we need to make sure of. So one, you'll notice that the whole top and bottom is now only recognized to be the face that we selected. It doesn't include that chamfer at the top, and it doesn't include the drill tip angle at the bottom. If I turn on this checkbox here, auto merge hole segments, it was kind of faint there, but what it does is it looks at the hole that you've selected and it will work its way up the model until it finds, it no longer finds concentric features anymore. So this is really handy if you're doing counterbore holes because you can select the drill diameter, or you can select the face for the through hole. And when you turn on auto merge hole segments, it will recognize the entire hole feature from top to bottom instead of just that segment you've selected. Okay. And again, to drill the tip through the bottom, I just need to turn on this checkbox. And you can see there it matches up perfectly. I've used a 118 degree drill. The feature was made to be 118 degrees. So that's really nice. And while we're here, I want to point out something that might be confusing to users that might be using the drill operation for the first time. But you'll notice that the green line here, which represents the area that the tool will feed, we start feeding the drill way off the top of the hole. And that's because the feed height is set by default to be 200 thousandths from the top height. Note that all of these heights are relative to each other. So we have the top height as the whole top, and the feed height, which is the plane that the tool starts feeding from, is 200 thousandths above the whole top. If I set that to 0 and zoom in a bit here, you'll see the green line has dropped. It might be kind of faint for some users. Sorry if it's too faint on the video. But now the tool is starting exactly on the whole top, which might not be desirable because it rapids up to that point. So it's usually good to include a small distance in the feed height. That way you don't rapid all the way up to the face and then start drilling. Handy tip for someone that might be confused by that. Al, anything you want me to include here?
No questions yet. I think it's so far people are picking up just fine, CJ.
Great. Okay, so with the basics,
you know what might be interesting though, now that you've got the heights shown, just show how those heights are relative to each other. So if you adjust maybe the feed plane, show how the retract plane can be related to the clearance plane is related to the retract height, for example.
Yeah, so the most obvious one right now is that I have the retract height and the clearance plane shown, and if I drag one, it moves the other. All right, so if I type in a number like 375, nope, I hit enter too quick there. So if I change this number, it changes the other relevant planes. When the plane is relative to a feature on the part, the plane is not shown. So for example, the feed height right now is shown from the top height, so it's not showing that plane. If I said, let's say from model top, see now it shows the plane. Okay, that's a helpful tip if you're wondering why those planes weren't shown. Okay.
Good. I think that's the basics. Let's jump into some more interesting stuff.
Yeah. So selecting multiple holes is really where the drilling operation starts to shine. We can do all the selections that we want for one hole, and it will automatically detect all the other instances of the hole, whether that be the same diameter, distance, and things like that. On this particular part, I have two sets of holes. The 6 holes on the left are 1/4-20. The 6 holes on the right are 1032. So let's just start with the 1/4-20 holes over here. The way I've modeled this is I have the minor diameter drill, and then I have the major diameter for the tap. And this is handy to model because once you select these, you can modify them in the design workspace, and your hole depths automatically will adjust the drilling operations. So let's start with spotting these holes. So I'm going to select a tool. I don't have a spot drill in this operation or this document yet. So I'm going to look for a spot drill. And I want the diameter of the spot drill to be greater than 1/4 inch. So now I'm looking at all spot drills available in any of my libraries. So let's go ahead and use this 3/8 spot drill. Okay, so I've got my spot drill. Go over to geometry. And on this part, I already have a chamfer on the top of the hole. It's pretty common that if you select a hole and you want to get a specific diameter on there, you have to calculate using trig to figure out how deep your spot drill needs to go for the angle and things like that. In Fusion, all you need to do is select the face, and it will automatically detect the depth that it needs to go to. And I've modeled that chamfer as a 120-degree chamfer. I like to use 120 degrees when I'm doing tapped holes. And I've selected a 90-degree spot drill. So you can see it's automatically gone to the depth that it can in order to not violate that feature, in this case, the bottom of that chamfer. And that was determined by just declaring the bottom height to be the hole bottom. Also, right now I have that tool as a virtual sharp, so a 90-degree zero diameter tip. If I go back to the tool definition, So let's take a look at our whole series. Looks like I already had a spot drill in there actually. If I edit this tool and go to the cutter tab and look for tip diameter, this value here, I could put in something like 50 thousandths. Maybe it was a little hard to see on the preview there, but now the tip of the spot drill is flat, which is extremely common for these tools. And that will automatically be calculated and included. Okay.
And just as a quick aside, sometimes it doesn't seem like it's important to dimension that flat when you're modeling it inside of the cam system. But the reality is that that endpoint of the tool is how you're going to touch the tool off in the machine. And if the tool is touched off at the wrong distance, you're going to end up with these kind of spot drills or chamfers that are the wrong size. And also, if you use that tool to chamfer the edge of the part, you'll end up with something that's not the same size. And people often miss. The reason for that is in the cam system, you didn't define the width of that flat, and it thought the tool was a different length than it actually is.
Exactly. Okay. Let's see. Now that we've got our spotting operation, I just did that for one, right? Let's go back to an ISO view of this whole thing. I just did that one spot drill operation on that one hole, and I wanted to include at least all of the holes for the quarter 20s. So if I turn on the checkbox, select same diameter, it finds all the same diameter holes, or in this case chamfers, that are on this part. So it found all 6, including the ones that were at different heights. And right now it's ordering them from right to left, which is okay. This would mean that all 3 on the right get included and get posted in their own can cycle, and then the left 3 would. If we were on a part where the instances were staggered, we can separate those out by the can cycle, and I'll show you that in the next part because they are staggered in that one. Let's say that I also wanted to spot drill the holes on the right for the 1032. I could easily do that by including one of these chamfer faces in the selection. So by clicking on that chamfer, I'm both cutting the chamfers for the quarter 20 holes and for the 1032 holes, and it's automatically detected the depth between the two. So this chamfer is being cut at a shallower depth than the quarter 20. Let's use the name view there. Okay, so very handy. Looks like I exited the operation without saving there. Okay, so you can select multiple diameters in one drilling operation to select all of your holes. Okay, how's chat looking so far? Any questions? Anyone
You do
want to
have
stump the
a
chump?
side question about setting a default for the number of flutes in a drill. Maybe we can address that later. I'll just answer it in the chat for now.
Yeah, okay. Sounds good. All right, so moving on. Now we want to do the minor diameter drill for the quarter 20 hole. So I'm going to select the drill operation, select the tool. Again, I don't have a number. I happen to know off the top of my head it's a number 7 drill. So I'm going to search for a drill. And in the search bar here, I'll type in number 7. And it should show me a few here. And it does. Here's the number 7 drill. I have some cutting data for different materials in here. The aluminum drilling preset will work just fine. These are for high-speed steel. If you have carbide drills, obviously, you can push them much faster. Go over to geometry now, and I'm going to select the face that represents the minor diameter. Okay, and let's zoom in on that. And you can see it's right now it's currently rapiding to almost the bottom of that hole and then doing that one section. So we want to turn on auto merge hole segments, and you can see that automatically found all the other concentric segments that went up to the top of the model. I'm going to turn on drill tip through bottom. Okay, so that's exactly what I want there. And then I'll turn on select same diameter. And let's zoom out here and see what happened. Oh, I clicked the name view and it bumped me out of the operation. Let's try that one more time. It's much quicker when I go through it the second time. And auto merge hole segments. Okay. So you can see when I have all those settings enabled, it found all of the same diameter holes, and it also detected the correct top to bottom distance of each hole. So through one selection, I was able to drill all the holes on the left and all the holes on the right. However, let's say that you really needed to separate out the selections of these because maybe you needed a longer drill for one and a shorter drill for the other, or you want to inspect them differently. There's all sorts of reasons that you will want to control what you're including. So let's edit this operation, go back to the geometry tab, zoom out a bit so we can see. And you'll notice that when we turn on the select same diameter checkbox, there's some options that appear and disappear. And the two that I want to point out here, one is hole depth, so only same hole depth. And then the next one is only same Z top height. Okay, so the same hole depth, what that does is it will only find holes that go the same top to bottom distance. So not the same absolute Z depth. What it's looking for is, in this case, any hole, like on the left, I have the hole going, for example, 3/4 of an inch. So it will look for any holes that are going 3/4 of an inch deep, regardless of where the hole starts. Okay. And I can't demo that right here because I don't have any holes that are different in that respect. But I have this option, select same Z top height. Okay. So, oh, actually, that's kind of a problem right now because the selection's all the same top height. But if I include this guy in here, okay, despite the same diameter being on all these other holes over here, it's only finding these holes because they are starting at the same Z top height. If I uncheck that, of course it finds the other ones. Okay, so that's really handy if you're trying to select as many holes as you can automatically, but be smart about which ones you want to include.
And why would you do that? I mean, I can think of one example. Maybe on the deeper holes, you're using a different drill, or maybe a pecking cycle on the deeper holes. There's just trying to give some examples of why you might want to do that.
Yeah, you might want to change the drilling cycle type. You might need to dwell in one longer. You might need to take larger pecks in another. You might need to use a different tool. I mentioned that one earlier. Maybe you want to select a different tool for different depths of holes. Another one could be like on the part that I'm going to show next. On the real part that I made that inspired that one, I had to inspect the holes in the order that they were cut. So I'd have to cut the holes, inspect them, sign off on that, and then run the next ones. That was just part of the inspection process for that part. So there could be non-machining, strictly machining reasons you might want to order things in a particular way or include or exclude. The next one that is pretty special is the containment boundary. So let's select this minor diameter one here at the bottom again so we get our holes. The containment boundary allows you to select an area that limits the whole selection. So right now I've got that, so that's going to exclude it. I think I'll need to draw a boundary. So I'm going to design. I'm going to draw a sketch, and I'll just draw a rectangle around these holes. Right now it's not important to dimension it or anything. But if I edit this operation, go to geometry, and then make a selection for containment boundary, notice only holes that are in this containment boundary are included in the same diameter selection. So this could be good if you need to also exclude specific holes. You can draw a boundary around all the holes that you want, then you draw a small contour around the holes that you want to exclude, and when you make that selection, it will include or exclude just what you need based on its location. Okay. We've been spending a lot of time on this one, but that's okay. Bottom line here is it's tapping all the holes that I want, so that's good. Let's go ahead and hide that sketch. And we'll move on to the tapping. So I'm going to select a 1/4-20 tap. I can just type that in here. And I get a few options. Tim's library had some 1/4-20 options in there. The Pier 9 Matsura library has some in there. Here's an example 1/4-20. And this time I'm just going to select the major diameter there. That gets me the depth that I want. Turn on select same diameter. Finds all the same diameter holes. And make sure auto merge hole segments is on, so it's looking at the hole from top to bottom. And that's exactly what I want. Let's say that when you tap a hole, the first couple of threads aren't full threads because that's where it's entering the hole from. So let's say that you modeled this in such a way that you need this section to be all full threaded. If I go to the heights tab, there's two ways you could extend how far it's going. You could also drill chip through bottom and specify a distance, right? So if I put in 50 thou there, it'll go 50 thousandths past the selection. So that's handy. One thing to note is that this breakthrough depth is always a positive number. The alternative method would be to leave this selection at hole bottom and put in a negative offset. So I could put in minus 50 thousandths and it does the exact same thing. Okay, so if you're trying to select faces on the model and it's not going exactly where you want it to, you can adjust these numbers relative to the selection. Another thing to note is that in the past, I've received models and drawings where the model did not match the drawing at all. For example, a hole was modeled to be 1/2 inch deep, but they actually wanted the drill to go 3/4 of an inch deep. If you needed to address that, you could say from hole top, I want to go minus 3/4 of an inch. Okay. So this is kind of a hybrid where I've recognized the hole top already, and on the drawing it says this needs to go this deep. So if you type in a negative value relative to the top, that'll get you exactly what you want there. I've seen that all too often where the model doesn't match the drawing exactly. So this would be a method to get around that. Okay, let's set this back to defaults. Any other questions or things I'm missing here?
And there are some questions around using the hole recognition feature, and maybe we'll just keep that until the end. So I'd keep going.
Okay, great. And you notice through this whole process, I just did it for the 1/4-20 so far, not the 1032, but it's not picking up the other holes there. That's because the seam diameter function is very accurate. It works really great. Okay, so I think we've done enough on this model. Let's jump over to this part because I think this really demonstrates the strengths of using the select seam diameter option and utilizing those switches. So if I do a wireframe view of this part, okay, we have a couple of holes on the corner there. So there's 8 larger tapped holes, and then there's all these little 256 holes. And what's happening here is that there's a longer hole and a shorter hole, and the long hole on the upper and lower level are the same depth, and the shorter holes on the upper and lower levels are the same depth. Okay, I hope that's obvious. But the way these are called out on the drawing, let's go back to, first let's go to an ISO view and go back to wireframe. Sorry, visible with edges. The way these are called out on the drawing is there's series A, B, C, D, and here's the short ones on the upper level, here's the short ones on the lower level. So it's really nice to be able to separate these out per operation, especially since the real model that I got were the the values called out on the drawing were not what I saw on the model. So it was important to break those out and be able to type in some values manually. But let's go ahead and spot all these holes. And I'm going to use that 3/8 spot drill. No, that's too big actually. Let's just make sure that the tip diameter is small on that one. Okay, so leave it 120 degrees. Tip diameter, let's just make the tip diameter 10. Keep it simple. Okay, so I've got my spot drill here. Now, instead of selecting the faces that I want for this, I'm going to change the hole mode to diameter range. So what this does, it allows me to specify a range of holes that it will look for. And let's go up to, what was the other one? Okay, so it found all those holes there. And I should be able to put in a chamfer width and say I want that chamfer to be 15 thousandths. There you go. So with one operation and some intelligent geometry selections, I was able to spot all of these holes regardless of its size. And let's just do a front view here to verify. Oh, actually, it looks like a couple of those. Oh, that's just because I'm looking at this 1/4 inch hole in the back here. All these other ones are perfectly fine. Looks good to me. Okay, so we'll keep that spot drill operation. And for the 256 tapped hole, it's a 70 thou diameter tap drill, which is a number 50 drill. So I need a number 50 drill. Type in 50. Gives me a couple options here. Oh, I've already got one selected, so that's good. Okay, so I'm going to zoom in on one of these holes, and I've modeled it the same way where I've got the minor and major diameter in here. So I'm going to make sure I just select that minor diameter. I'm really searching in there for that. Well, where'd my operation go? Just a second here. You know what? Did I lose? Oh, I don't even have the operation open. Whoops. Okay. Number 50 drill. Zoom back in there. Okay. That's the hole that I want. Turn on auto merge hole segments. Okay. So it's looking for everything that's concentric going up. So that's good. And then I'm going to zoom back out for this, but I'm going to turn on select same diameter, and it's found everything. Okay. Which in and of itself isn't that bad. That's perfectly fine. But I do want to separate these out. And you notice it starts over here on the right, and it's kind of spiraling around the part, doing all those holes in the order that it finds. And that's because the order is optimized. And I'll check out a few of these other options. But let's just make sure that we're doing the holes that we want. So first, I only want to do the short holes on the upper level. And so this first hole that I've selected is one of the short ones. So first I'll turn on same Z top height. Okay. And it's already pulled the same hole depth ones. Okay. And that's because the hole that I selected in there on the minor diameter starts at a different depth than these longer ones here. So actually I didn't even need to select same hole depth. Okay, so that's pretty handy there. I can call this one Series A. And I'm going to duplicate this operation because I've got all the same settings I want already. I'll call this one Series B. And I'll just select the minor diameter on the other hole next to it. Okay, super easy. And if I highlight both those operations, you can see all those holes have been drilled. but I was able to separate them out by their depth. So I'll do the same thing 2 more times. Call this one C. Call this one D. Select one of the holes down here for that one. Select OK. Open up the Series D operation. And I'm going quick just to demonstrate that it's really fast to do this when you're using this operation. Even without feature recognition, it was really quick to do all of those and separate them out. And now, let's say that this whole series here, maybe it was modeled differently than it was called out on the drawing. So now just for this series, I can say, well, from the whole top, I need to be minus 200 thousandths. Right? This is, I know it seems kind of asinine to do it this way. And it's not even like, this isn't something we'd show at AU main stage. But this, when people are actually making parts, this stuff becomes really handy. Hopefully Steve Hooper wasn't listening. Al, do you have anything you want to add to that?
No, I was just following up on a few tangential questions about sketching, to be honest, in the chat. So
okay.
You can stay focused on the drilling side.
Cool. Well, unless someone has any specific questions they want to go over, I can get into some other more advanced things, because I have a default expression that I want to demonstrate, but it takes a minute to set up. So
I don't see any specific questions yet. So why don't you do that default expression thing and walk us through that?
Okay. So there's a really cool trick that you can do regarding a default expression, a template, and the formula for tap drills. And shoot. Can't remember the gentleman that demoed this to me, but I need to make sure I give credit where credit's due. If I can find his... Yeah, Phil Brown. I got to give kudos to Phil Brown for showing this to me, and I thought it was brilliant. So here's what we're going to do. I want to create a template operation that automatically recognizes a minor diameter hole for a 1/4-20 tap. And so what I'm going to do is go back to this hole feature. I need this to be 0.201. Okay, so I have a 0.201 hole here. And what I would like to happen is I would like to create an operation that when I select a tap, it automatically will calculate the minor diameter using the formula for calculating like a 75% thread, and it will automatically find the correct hole, actually regardless of whatever tap I choose. So first I need to find what that formula is. So excuse me for a moment while I Google this. Okay. That wasn't it. Well, the formula for metric is a lot easier than the one for imperial. Maybe I just need to do that. Let's do it for a metric diameter thread. That way I don't have to search for this giant formula, because the idea will be clear.
Maybe just start walking your way into this and show how you can first link the tool diameter to the selection and then get a little more advanced.
Yeah. So if this is a 201 hole and I pick a 201 drill, I had a 201 drill. Yeah, here we go. Okay. If I select diameter range, and if for the min and max I put in 201, that's automatically recognizing that hole. I didn't have to select that. Okay. So conceptually, what I could do is instead of writing that number, I could say that this is the tool diameter. Okay. So let's save this as a template. Let's call this number 7 hole. Save this as a template. So store as template. Template name will be number 7 drill. All right, we'll delete this operation and let's recall that template. So create from template number 7 drill. When I generate this operation, it detected the hole. It already found it. Okay. So in concept, you could use this idea of putting the tool diameter in the range for an operation, and it effectively becomes an automated selecting drill operation. Let's mess around with the design a little bit. Let's see if I can get this to let's suppress these features here. Let's do a linear pattern of the body. Let's do a few of these. They're 1 inch wide. And let's combine. Whoops. Okay, so I've added some holes in there. If we go back over to manufacture, regenerate this operation, finds all the other ones. Okay, so this would have happened with select same diameter as well, but you would have had to start out by selecting a diameter. In this case, it just finds the hole based on the tool that you've selected.
Maybe just draw a new part with a hole the same size and copy and paste the operation to show that.
Yeah, that's a good idea. Just do some random placement of those, make them equal. Okay, that looks good. Make that 201. Extrude this up. Okay. I'll create an operation so that I have something or a setup so that I have something to paste into. Jump back over to this document, copy the operation. Jump back over to my new part. Oh, actually, I didn't even have to do that. I could just create from template. Sorry.
But copy and paste between is also good for people to see.
Yeah. So that was a operation generated from the template. I could just as effectively paste the operation that I copied and generate that toolpath, and it makes a selection. So the way this could be used, if set up correctly, is you could have a spot operation, a minor diameter drill operation, and a tap operation be in a template. And if you're using diameter range and calculating the diameter range in this way, you have automatic selections of tap tools that do all the operations for you. Really awesome.
What you could even do is have multiple of those operations together in the same template. And if there's holes, it'll drill them. And if there's not holes, it won't. But an empty operation's fine.
Exactly. Let's, if I change the diameter of these holes to something that is not the tool diameter, these operations simply just don't drill those holes. Nothing. Cool. That's about all the content that I have.
Let's give a minute for people to ask some more questions on drilling. And while that's happening, there's a user that asked how to create text in a sketch. And it's a complete tangent, I know.
Yeah.
But do that for 30 seconds while the folks that are more interested in drilling spool up some questions.
Perfect. So for the text, I'll just extrude a little rectangle here. Okay. And now I'm going to start a sketch, and I will draw a line. Okay, this is where the text is going to go. And on the create dropdown, there is a text option. So if I select text, or I'm sorry, I didn't have to create that line first. That's muscle memory from something else. But all you have to do is select the text option, determine where you want it to go using this point object here, and you can type in your text.
Maybe just to kind of take this a couple steps, because we're talking about associativity and why associativity matters. Create that text, and then let's create an engrave operation selecting the text. And if you select the text properly, then when the text changes, the toolpath will update accordingly. So
yeah,
be a neat little thing to show. And again, while CJ's doing that, it looks like there's some questions around templates or some excitement around templates as well as drilling. So if you've got some more specific questions about how you could use templates, feel free to throw that in the chat.
Okay, and then select the text for that operation. Should give us some nice.
So see, when he selected it, though, he didn't select it individually. He selected the highlighted text, and it got all of the sketch at the same time.
Exactly.
Bit of stock on the top that makes it look like it's cutting too deep.
Yeah, that's right. Let's get rid of that from the setup there. So make all this 0. Good call out. There we go. Let's see if I can change this to comparison. There we go. And it's red because I think it's
change the text and show how it updates you if you change your text back in the modeling space.
Okay, let's change this to
not necessarily a different font, just type something completely different too. Completely different. Well played.
Oh, let's make this a little there we go.
There we go.
Yeah, and that's just based off of selecting. I selected one letter, but it highlighted the whole text. So all of the text is included in that operation.
Okay, I see a question. I'm just trying to understand it. The process of threading in drilled holes. So maybe show some of the tap cycles, as well as might be worthwhile showing thread mill as well.
Yeah, let's make a bigger hole for that one.
Yeah, and then we could actually show that the thread milling operation also has select same diameter.
Yeah, which is a great improvement. Now let's just do 1/2 inch here. Okay, so let's assume that we've already drilled this out to the minor diameter. It's a 1/2 inch. I guess a 1/2 inch 13 thread, for example, would be fine here. So if you were going to tap this.
To be honest, CJ, you're getting all kinds of people excited when you started talking about metrics. So any metric examples will have the current viewers pretty excited.
Oh, yeah? Okay. Well, what's an appropriate metric thread here? This would be 12. How about 12 1.5? So here we go. Instead of 1/2 inch, we're going to make this 12 millimeters. Nailed it. Okay, so we can tap this. And we do have a couple of options for tapping. Let's look at the ISO taps. I want a 12 1.5. There we go. Okay, select the hole. I can give it a little bit of breakthrough here. And for the cycle, because I selected a tap tool, it automatically defaulted to the tapping cycle. We also can explicitly ask it to do left or right hand tapping. Generally, tapping and right tapping result in the same cycle selection in a post. But the next one that's special is tapping with chip breaking. So this is like peck drilling, but with a tap. So it will go a specific distance with the tap, then pull back out. Then it'll go in a little deeper and come back out. Really good if you're doing hard materials, or you're worried about your tap breaking, or you're worried about chips packing in the hole, things like that. Works really well. I can attest to it working perfectly on the Haas machine already. You would have to make sure that your post is set up to do peck tapping if you're going to use this. Sometimes it needs to be configured on a per machine basis. Next would be thread milling. Sorry, Al, did you have something you want to say?
No, you're good.
Okay. So I did that kind of quick. Under 2D operations, we have the thread operation. So thread, bore, and circular are all for cutting circular features. The thread operation specifically has some settings that are nice for creating thread milled holes. And for the tool, you can choose a thread mill, or you can choose a tool type like a flat end mill or bullnose end mill or a slot mill. Basically, any mill that represents the tool that you want to use is compatible with the thread operation. So I can, for example, just use let's just make a 6mm tool, or 6mm flat end mill. Overall length, yep, that'll be fine. Okay, so we got our tool. Go into geometry, select the hole, and you see we get a preview for the thread milling operation. And we have the same select same diameter option in the thread milling operation. So if you're drilling a bunch of holes and then thread milling them out later, you have the same options to do that. Okay, that includes same hole depth, same Z level, and containment boundary. So if you same selections you use in the drill operation, you can use here. As far as the heights go, you'll notice right now, if I do a wireframe view, okay, right now the operation is thread milling the entire feature from bottom to top. And let's say you're using a multi-point thread mill, and you only needed to do one pass. There is a way to handle that. And what I'm going to do right now is I'm going to make all the lead values 0 so that we just see cutting. Okay, so you can see that the tool path is starting down here on the bottom at about a 90-degree angle from us right now. And the thread pitch here, we said this is going to be 12 1.5. So it's going to be a 1.5mm thread pitch. And I'm going to check the name of this parameter. So I'm going to hold shift and hover over the parameter, and it should give me a tooltip that gives me the name of the parameter, which is thread pitch with a capital P. Okay, this is important. I'm going to go to the heights tab, and for the top height, remember we're going from bottom to top for this thread operation. So I'm going to set the I'm going to set the top height to be relative to the bottom. So right now I have no toolpath because they're equal. And I'm going to input thread pitch. Okay, so now this is giving me one thread pitch. And I could, for example, say thread pitch times 1.5, and it gives me 1.5 rotations. Or I could say 2, and this gives me 2 rotations. So this is an easy way to give you just the number of rotations you need in your thread mill toolpath if you have a multi-point thread tool.
Very good. I hope that was helpful.
Yeah, I'm wondering if there's any other questions about thread milling.
I don't see any, and we're getting close to the top of the hour. I want to be respectful of people's time. So uh, why don't we wrap it up if there isn't any more questions? We'll give a second here.
Okay. Awesome. Well, I hope everybody had an opportunity to learn something on this webinar, even if it was just one little checkbox. I've been getting feedback from people reaching out to me personally, and they say, "Oh yeah, the webinar was great, and just these 2 seconds were worth the whole hour." So uh, it makes me happy when I get feedback like that.
Yeah, we got some thank yous. So we can wave bye and enjoy your weekend, everybody.
Let me show us again so we can wave.
Oh, there we are.
Yeah.
Okay.
Bye everybody.
Thanks for joining, especially you guys at the end of the day in Germany and in Europe. Uh, Pretty exciting to see what a passionate user community we have. So please reach out to CJRI anytime. We certainly enjoy connecting with you guys. We're not connecting in person as much lately, but this is a new way of connecting, and I hope you find it helpful.
Awesome. Thanks everyone. Bye.
Bye.